I'm excited to see so many people here who are interested in log analysis. Yay. So my name is Sarah. I'm a grad student at Berkeley. And I'm going to tell you about an analysis we did of queries from Splunk, a highly popular tool for analyzing log data. This work is in collaboration with Archana at Splunk and also 2 senior undergraduates in CS at Berkeley who are here in the audience. Can you guys stand up and wave? So the data we have is like this. We have users who are interacting with this log analysis tool to study their data and answer questions they have. And to do this, they issue a set of queries. So this is what we've collected. Why might we look at this data? Well, it kind of depends on your perspective. If you're a practitioner, like many of you might be, you might be interested in learning about best practices or how you can improve your log analysis infrastructure. If you're a company that makes data analysis and management tools, you might be interested in how you can be more relevant to your customers or improve their experience. Or if you're a researcher, you might be interested in inventing new methods for analysis or coming up with novel applications based on this data. So I'm going to focus on the sort of first 2 perspectives, and the question I'm trying to answer is, what do people do with this tool? So this is going to be one of those talks where hopefully you feel like you learned something about the way the world is. So how many people are familiar with Splunk? Oh, great. Okay, so I don't have to go over this too much. So yeah, this is the sort of default GUI. You enter your search in the bar at the top, and then your events are at the bottom, and you express your queries in a proprietary language. So an example of a query in this language is this. So it's a pipelined language, and so this is 3 stages in a pipeline. The first one, you look for the string error, and then the second stage just groups those, all the events by the status field, and then the third stage joins that with the description of that error code. So what kinds of questions can we ask about queries like this? From the practitioner's viewpoint, you might want to know, what are the primitives of log analysis? What are the main tasks that people do? And why do people do that? So to focus on the first question, you can start by simply looking at what commands are used, like this list here, which shows a count of the number of times each command appears in the data set. And note this list has been cut in the middle because it's too long. But this doesn't tell you very much if you're not an expert in the Splunk language, and even if you are, it still doesn't tell you very much. If you look at the distribution sort of stacked by rank, well, one thing you'll observe is that some commands are used most of the time, and most commands are used none of the time. But this is sort of limited in how much we can get from this. So what we did instead was to impose a hierarchy on these commands and classify them into different types that sort of said more about how they transform data. So for example, augment commands are those which add a column that is a function of other columns in the data. Filter removes events. Aggregate you're familiar with. So then when we do this, we can get a more clear picture of what people use Splunk to do. So the top graph shows for each of the stages, so I showed you a 3-stage query before, so we looked at all the stages in the data set and classified them. And then the bottom graph shows the number of queries that contain transformations of that type. Okay, sorry about that. Okay, so the reason cache is so high is one caveat I didn't mention is we looked at scheduled queries, which are kind of like cron jobs, and not just interactive queries because of a provenance issue that we had. So ignoring that, and also macro, which is just macro, we don't have much visibility into what those are, aside from we can tell you that they're pretty diverse, like there's no one macro that everyone's using. But aside from those, the most common types of transformations are filters, aggregations, augments, which I mentioned already, transformations, which are kind of like augments, but instead of adding a column, you're just changing a column, and then renaming and projecting. So project is just like a SQL select kind of. This isn't SQL, but you get the idea. So this is a lot more clear picture of what people are doing. But But we might want to know at more detail what is the sort of filter that people apply? What are the sort of columns they're adding? So to answer this question, we first split all the queries into stages again. Then for each of the stages in the categories of interest, we focus on filter and augment and aggregate because they're the most common. We then performed PCA on these feature vectors that we got out to reduce the dimensionality. Then we performed another step to project these into 2 dimensions. And then we labeled the resulting clusters. So this is kind of what the points look like after we applied TS&E, and then I've also color-coded and labeled these. So we used a little tool to explore these. We also, now that we have this, we can sort of look at how many of each type are there. So in terms of filters, the largest category consists of these long logical conjunctions or disjunctions of other atomic types of filters, which correspond to things like looking for fields which have a certain value, doing string matching, so like grep, basically just selecting out data, which is kind of just like, select star from table. You can think of it being kind of like that. Deduplication and time range queries. One thing I should note is that the queries don't capture everything in the system because actually the time can be constrained in Splunk using the GUI. So this is just sort of a reflection of how hard it is to capture everything about how users use your system and how you kind of have to plan ahead. So in terms of augment transformations, the most common types are adding a column which is some sort of string function of other columns, so you're splitting a string or extracting a string or reformatting it. Adding a column which basically is basically categorizing each event or categorizing other fields using an if statement. Doing simple arithmetic, date time manipulation, list operations, and simple renames. And then in terms of aggregation, the main types are just sort of basic aggregation, aggregating over time. So bucket the data first, then aggregate those buckets. Do that same thing, but visualize it. And then also top. So you're aggregating by something, and then sorting it, and then taking the top ones. So now that you have a pretty detailed picture, like this is what a log analysis activity looks like. Okay, great. So you might want to know who are these people who are doing this log analysis and why and that sort of thing. So we also conducted a survey of our sales engineers about customers. And we asked a bunch of questions, and you can find a discussion of these in the paper, so I'm going to only have time to go over a few of these. So the main questions we asked are, who are these users? So as you might expect, most of them are IT and engineering, but not all of them. So interestingly, we see people in management, in product management, in marketing, sales, also working with log data, and even people in manufacturing, and so on. They tend to look mostly at sort of IT logs, like you'd expect, but there's a real diversity of sources here, including not only just sort of typical bread and butter network logs, performance logs, firewalls, and that sort of stuff, but also customer data, sales data, sensor data. And lastly, what kind of questions were they trying to answer with Splunk? So these, again, are mostly IT-related questions, but also this includes a lot of different types of activity, and again, some more customer-facing use cases. So there's a lot more stuff in the paper. I talked a little bit about the tasks, subtasks, and a little bit of the survey. We also looked at sequences of operations that people perform. What we didn't look at, because we don't have access to this sort of data, is questions specific to like how users are behaving and how the specific data you have influences the type of analysis you apply. And what also I didn't get a chance to talk about is the challenges associated with analyzing this type of data. It's very messy and complex. There's dirty provenance, as I alluded to. So this has led to a workshop paper that we wrote about how to improve your instrumentation for systems to gather this kind of information, which I encourage you to check out if you're interested. As I mentioned, there's some other things. So to sort of help other people who might be interested in looking at their own Splunk data, we are releasing the scripts and stuff that we wrote for this. So if you're interested, I encourage you to talk to me about that because it's sort of still a work in progress in terms of documenting everything. And so just to summarize, so 87% of log analysis activity, once you take out caching and macros, are these 5 things that you can keep in your head. They're kind of simple. You're filtering, adding columns, aggregating, renaming, or projecting. And I kind of consider these 2 types of tasks here, data cleaning and then also troubleshooting, which encompasses when people are looking for like, specific strings in the data. And so the use cases, troubleshooting and security, as I mentioned, fall into the one category, and then report generation, monitoring, and so on in the other. And then also we are starting to see more people look at logs who are not just in IT. So I think that sysadmins and other people who spend a lot of time doing log analysis have an opportunity to facilitate this sort of activity for other people who fill other roles in the organization. So lastly, I just wanted to mention that the 2 co-authors on this project are graduating in May. So if you're hiring, I encourage you to say hi. And the office hours are tomorrow at 4.
Simon O from Kansas State University. So very interesting work. Could you talk about where you got the data that you obtained those statistics?
From Splunk.
The company provided you the data from their customers, essentially.
Yeah.
And do you have
should leave it at that.
Yeah. Do you have any idea on what type of organizations, how many organizations, how many analysts that are represented in that data?
I can say that it's on an order of hundreds of organizations. I'm not sure about the number of different analysts. But yeah, we tried not to get too specific into anything that could be, we try to keep it at sort of an aggregate level out of sort of respect for privacy of customers. So unfortunately, I can't really say more about that.
Okay, thank you very much.